Welcome back, everybody, for another deep dive. This time, we're going to be talking about something that's pretty cool. It's where, like, cutting-edge AI meets the hands-on world of truck repair.
Right.
So, all that experience that, like, veteran mechanics have about diagnosing those crazy chain reaction breakdowns.
Yeah.
Like, what if we could make that accessible to, like, anyone? That's kind of like what this research paper that we're diving into today is trying to do.
It really is fascinating to see that blend of a traditional industry with this kind of really advanced tech.
Right.
And the paper really highlights the urgency of this, and it all boils down to two key factors, really.
Okay, lay it on me. What makes this so urgent?
Well, first, you've got even seasoned mechanics struggling sometimes because trucks are such intricate systems these days.
Yeah.
One tiny fault can spiral into this whole cascade of failures,
Right.
making diagnoses really tough.
Yeah, it's like one of those domino chain reaction videos, but instead of cool patterns, you've got a very expensive truck down for the count.
Exactly. And then the second factor is, this research comes out of Japan, and they're facing a real shrinking workforce.
Right.
Fewer new engineers are coming in.
At a time when the tech is getting more complicated?
Exactly, at a time when truck tech is getting more complex with all the electric and automated stuff.
So fewer experts and more complex problems.
Yeah.
Okay, I see why they're trying to capture that knowledge somehow.
Right.
The paper mentions that, truck companies already document failures, but it's not exactly easy reading for a newbie, right?
No, not at all. It's like trying to learn brain surgery from a stack of patient files.
Oh, wow.
Lots of detail, not a lot of user-friendliness.
Right.
And so that's where this idea of a knowledge graph comes in.
Okay.
Or KG.
Okay.
And it's about organizing that information visually.
Okay.
And showing how all the parts connect and how failures can cascade.
So like a flow chart, but for truck breakdowns.
Yeah, that's a really good way to think about it.
Okay.
Actually, there was a previous attempt to do this with the KG, but they found that even the KG itself was too complex.
What?
So going back to that brain surgery analogy, it's like giving someone a very detailed anatomical chart when they don't even know basic biology yet.
So we need a translator.
Yeah.
Something to bridge the gap between the really complex information and someone who's just starting out.
Exactly. And that's where the big AI players come in.
Okay, so this is where we start getting into the AI.
Right. You think about the power of something like ChatGPT. It can analyze so much information so fast.
Right.
Imagine that applied to all of those failure reports.
Okay, so instant expert advice right at your fingertips.
Potentially, yeah.
But I'm guessing there's a catch.
There is a catch.
And ChatGPT doesn't exactly have, years of experience fixing trucks, does it?
Exactly. It lacks that real-world, company-specific knowledge that is tucked away in all of those reports.
Yeah.
So it's like having a brilliant detective
Right.
who doesn't know the city that they're investigating in.
Okay, so how do we give our AI detective a map of the city?
Well, that's where Retrieval-Augmented Generation comes in, or ARAGs for short.
I agree. Okay.
And what it does is it lets these powerful AI models called LLMs tap into external databases, like our fancy truck failure knowledge graph.
So it's not just about the raw processing power, but about giving it the right knowledge to work with.
Exactly. And the paper focuses on something called GraphArag.
GraphArag, okay.
Which is specifically connecting those LLMs to knowledge graphs.
Gotcha.
But even then, there's two main approaches with their own little quirks.
Okay, so hit me with the options then. What are we working with here?
So we've got semantic parsing.
Okay.
Where the LLM actually learns to speak the KG's language.
Oh, wow.
So it translates your question into a database query that can pull out the right information.
So it's like teaching the AI to read like a technical manual or something.
Exactly. And then you have information retrieval, or IR. And this is where the LLM acts more like a super-powered research assistant, finding the most relevant clusters of information within the KG.
Okay, so instead of translating the whole manual, it's pulling out the key chapters based on your question.
Yeah, a much better way to put it than I did.
But the researchers found that traditional GraphRag wasn't quite cutting it for this problem.
Yeah.
What were the roadblocks that they were hitting?
Well, one of the biggest issues is that a lot of these existing KGs, like the one for trucks, weren't really built with LLMs in mind.
Okay.
So semantic parsing is really tough. It's like trying to fit a square peg into a round hole.
Yeah. The language barrier is an issue.
Huge issue.
What about the other approach, the information retrieval?
Well, here's the thing with that one.
Yeah.
Focusing on individual pieces of information misses the point.
Okay.
These failures happen in a sequence, one thing leads to another.
Right.
And that connection, how it all flows together, is key.
So it's not just about the ingredients, it's about the recipe.
Yeah, there you go.
So traditional graph rag wasn't quite the right tool for the job, it sounds like.
It wasn't quite there, yeah.
Which leads us to, I guess, the researchers' proposed solution.
Yeah.
So what did they come up with?
So they came up with a pretty clever system. It's an IR-based graph rag
Okay.
that's specifically designed to work with those existing knowledge graphs.
Yep.
And the Andy understands the relationships between all the different pieces.
Okay, so it speaks the right language.
Mm-hmm.
A&D sees the big picture.
Yeah.
All right, how does this wonder system actually work?
It's a 4-step process, and each step kind of builds on the last one.
Okay.
So first we have retrieving.
Okay.
The LLM scans the user's question and picks out the key terms.
So like a mechanic carefully listening to like what's wrong with the truck?
Exactly. Then comes extracting.
Okay.
The system uses those keywords to pull out relevant subgraphs from the knowledge graph.
Okay.
Those clusters of connected information we talked about.
Right, right. So it's zeroing in on the most likely trouble spots.
Yeah. And then next is filtering. Okay. Think of this like a quality control check.
Okay.
The LLM comes back in and makes sure that only the most relevant subgraphs are being used.
Okay. No distractions, just the good stuff.
Just the good stuff. And then finally we have reasoning.
Okay.
This is where the magic happens.
All right, hit me.
The LLM takes those filtered subgraphs, combines them with the user's original question,
Okay.
and crafts a clear, insightful answer.
So it's not just spitting out data. It's
Yeah.
like making sense of it, connecting the dots,
Yeah,
giving you something you can actually use.
exactly. It's like having that veteran mechanic
Well,
walk you through their thought process,
right.
showing you how they arrived at the diagnosis.
I like it. Okay, so that sounds pretty cool in theory.
Yeah.
But the big question is, how well does this actually work in practice?
Right. So to find that out,
Yeah.
they put it to the test.
Okay.
They compared their IR-based system to ChatGPT on its own
Okay.
and that traditional semantic parsing graph RAG.
Okay, so like head-to-head competition.
Exactly, head-to-head.
Let's see. How they stacked up, what were the results?
So their new system really blew the others out of the water.
Oh, wow.
It scored a whopping 157.6% higher
Wow.
than the semantic parsing system
Okay.
and 23.18% higher than ChatGPT working solo.
That's impressive.
Yeah,
Case closed, right? Problem solved.
not so fast.
Oh, there's a twist.
There's a little twist.
Okay.
While the results are promising, the overall accuracy scores were still a bit lower.
Okay, so it's on the right track.
Yeah.
But there's still room for improvement.
Yeah, there's definitely room for improvement.
What did they find when they kind of dug a little deeper?
So they did some additional experiments,
Okay.
and they discovered something really fascinating.
Okay, what's that?
Adding actual sentences from those original failure reports
Okay.
alongside the knowledge graph information
Right.
significantly boosted the accuracy.
Oh, interesting.
Yeah, so even though the KG captures a lot, it seems like some nuance is still only found in the raw text of those reports.
Yeah, it's like you can get the gist from a summary,
Right.
but sometimes you need to go back to the source material to get the full picture.
Exactly, and here's another interesting thing they found.
Okay.
LLMs might actually get more value from structured information,
Okay.
like that found in the KG, than from just raw text.
Interesting.
They're better at cutting through all that noise and finding those key connections.
So it's like if you give an LLM a jumbled toolbox,
Right.
it might struggle.
Yeah,
But if you give it a well-organized toolkit, then it can really shine.
exactly. So this research is really highlighting the power of structure, especially when you're dealing with complex knowledge.
Right.
It's like the difference between trying to navigate a city with just a street map
Yeah.
versus having a GPS that shows you exactly where you are and where you need to go.
Right. I like that analogy.
Yeah.
Okay, so this new system is a big step forward in making all that hard-won mechanic knowledge more accessible.
It is.
But I'm guessing this is just the tip of the iceberg.
Oh, yeah.
What are some of the future possibilities that have you excited?
I mean, imagine the system evolving to handle even more intricate scenarios,
Okay.
perhaps even predicting failures before they happen.
Oh, wow. So we could go from like reactive troubleshooting to proactive maintenance.
Exactly.
That would be huge.
Huge cost savings,
Yeah.
safety improvement.
Absolutely.
And it all stems from this core idea, capturing and sharing human expertise
Right.
in a way that is powerful and easy to use.
It's like democratizing knowledge.
Yeah.
Making it so anyone with the right tools can tap into the wisdom of those who came before.
That's a great way to put it.
Pretty powerful stuff.
Powerful stuff.
So we've been talking about this system that can kind of unlock all that mechanic knowledge.
Yeah.
Using AI, but it really makes you think about what it means to know something even for a really smart computer.
It really does.
Like we saw that the AI, even with all its power, it still benefited from having those real-world sentences from the mechanic reports. Like there's a level of understanding there that goes beyond just like crunching the data.
Definitely.
It's like that aha moment, when a mechanic's been staring at an engine for hours and then they suddenly see what the problem is. You can't put that in a database, can you?
No, you can't. It's the intuition, the years of experience, the ability to connect the dots in a way that goes beyond just pure logic.
It's what makes humans so valuable still, It's so hard to replicate that.
It really is.
So where do we go from here? If even AI is struggling to capture like the full picture, human knowledge, how do we make sure that expertise gets passed on?
That's the million-dollar question.
Yeah, to the next generation.
It is, and I think it really underscores how important human connection is in learning. Things like mentorship apprenticeships, that kind of knowledge sharing that happens when you have experienced mechanics working side by side with those who are just starting out.
Like there's the difference between reading a book about carpentry versus actually building something with a master carpenter there to guide you.
Exactly. You learn by observing, by asking questions. That back and forth is crucial.
Absolutely.
And it makes me think about, the need to create environments where that can thrive. Supporting mentorship programs, encouraging collaboration, finding ways to integrate that knowledge from experienced workers into training programs.
It's recognizing that the human element is still so essential.
It is.
Even in this world where tech is like advancing so rapidly.
It's not about choosing sides. It's about finding that sweet spot where human expertise and AI capabilities can work together.
I think that's a really good point.
And this research has given us a glimpse into that future of troubleshooting, where AI can augment and enhance human capabilities.
Leading to faster, more efficient repairs.
Exactly. But it's also reminded us that human knowledge, with all its nuances and complexities, is something to be valued and nurtured.
Very well said. I think that's a great place to wrap up our deep dive for today.
What is?
We've gone from this really specific AI system to some really big questions about the nature of knowledge and the future of work.
It's been a thought-provoking conversation.
It really has.
And to our listener, we encourage you to keep exploring these ideas, keep thinking critically about this relationship between humans and tech, and embrace those possibilities that are out there.
Absolutely, because that's what the deep dive is all about.
It is. Until next time.